Hello everyone, this is about my servo tester I'm making. I'm going to make a PCB out of it, so I might as well mention PCBWay. It's where I'm going to get my PCB made once I've designed it. So yeah, we all know about servos and how they work, I suppose, but I'll go through a few things. So we can have something like this. This is a nice tester, right? So basically we turn the knob and it turns the servo. So we can see the servo here. Actually, let's just see if I can get a bit of dark colour under there. It looks a bit... Give me a minute. Well, be right back. There we go. I just put a bit of contrast between the background and the horn that moves at the top there. So we can see with this really nice cheap tester, we can just do a bit of a test like this, and as we turn you can see that it moves through 90 degrees, so it goes so that's the centre, and I can move it that way at 45 degrees, and from centre I can move it that way from centre. It's got a button on it, we can centre it just to show you that it's centre, and then it's got another button that'll sort of do a sweep, so you can see that it's only actually moving through 90 degrees. And we know that these servos will go through 180 degrees, and this is why I am making my own servo tester. I'll try to explain why. So let's just put that back to manual so we can actually turn it like that. So right, what I'll do is we can forget about that tester now. That was just to show you that this tester actually sends the pulse width modulation to the servo at 50 Hertz, although you can't see that. And it's when you wind this knob, it goes from 1 millisecond all the way across to 2 millisecond pulse width, and that's the standard pulse width for servos. Let me just show you that. Right, I've just gone on the internet and just got a data sheet for this typical SG90 98 micro server, and we can see it says it goes 180 degrees. And what we can see is if I look at this sheet here, well, I did it better than that actually. Yeah, there we go, that's a bit bigger. So we can see here that we've got a duty cycle between 1 and 2 milliseconds, and that determines the angle of the servo, the horn on the servo. That's how much it turns. The minimum level is 1 millisecond, and the highest pulse width is 2 milliseconds, and that is a standard servo pulse width. And it repeats that every 20 milliseconds, which is basically 50 Hertz. So every 50 Hertz it will do a pulse either anywhere between 1 and 2 milliseconds. But what we can see down here, oh yes, so we can see down here it says position 0 will be at 1.5 milliseconds pulse. So if this is 1.5 milliseconds, it's going to be in the middle there. And if it's at 2 milliseconds, it's going to be at this point here. And then if it's at 1 millisecond, it's going to go 90 degrees the other way, which will be down about here somewhere. I'll show you this later with my with the servo tester that I've made. But I just want to point out that this was the standard pulse width for servos, but things have changed. Because we've gone digital, we're no longer analog. Now that digital's out, we can actually extend this, and that's what this has done. Now, if you'll see, oh, we've also got a dead band of 10 microseconds. I'll come back to that later when I'm just talking about my servo tester. Let's have a look at another data sheet. See, it's got the same thing here, but they've totally messed up. We've got middle is middle twice. Yeah. So the translation from the Japanese, the Chinese to English, or English one way or the other, has got mistaken. So let me just find another sheet. Right, let's try this one. So if we look, it says 180 degrees there again, but we know that in practice when I turned it, it only moved through 90 degrees. It went 45 either way at the standard pulse. So it was 0 at 1.5, but it was 40 at 2, and it was 45 plus at 2 milliseconds, and it was minus 45 at 1 millisecond. These the plus and minus tend to get swapped around, you see, and like I say, we've got dead band pulse width, so we're still okay there. Let me just go through. Right, yeah. So now, this is on the same. This is on the same data sheet, right? So the same data sheet, position 0, middle, 1.5 milliseconds, and then we go 91 way at 2 milliseconds, and minus 90 at 1 millisecond pulses. That's correct how it should be. But then this servo, the servos actually don't do that. So if we're using a normal tester that goes from 1 millisecond to 2 milliseconds, this is only going to turn 90 degrees because the pulse width for this is from 0.5 milliseconds to 2.4 milliseconds. So it's like another 500 milliseconds either way. We've still got the same pulse cycle, which is here, which is 50 Hertz. That's what that is. So I just want to show you that what they've done is they've reduced the pulse width down to 0.5 milliseconds and increased it to 2.4 milliseconds. So the actual where are we? Have we got a picture on this one? Yep, we've got a picture which sort of disagrees with what that we're just saying. So here the picture, they've used the standard picture. This has been copied over and over again by all sorts, which is the right one, which goes from 1 millisecond to 2 milliseconds. But what these servos do, they actually go to 0.5, so we're going back here again. Actually, can I draw that? Let me just get that out. Can I not do that? Oh, yeah, it's a web page. Oh, no, it's because it's not a web page. I wonder if I find a web page. Give me a minute. Actually, what am I talking about? I've got these tools here. So actually draw here. There we go, draw. So what they've actually done is they've increased this along here, and it now goes to here, and it also goes further back to here. So what we have, can we write text? I don't know. What's this? Draw. Nope. Hang on. Oh, is that it? Nope. Never used this before. Right, hang on. Hang on. Oh, that's translate that. Oh, there's add text. Right, so what we've actually got here is 0.5 milliseconds. Don't just press enter. No, don't. And now click somewhere else, I think. Right, yeah, so that's 0.5 milliseconds, and we go to 2.5 milliseconds. Okay, so this is the 2.5 and that's the 0.5, so we're extending this range of duty cycle that we have for these servos. So I hope that made a bit of sense, and I just needed to say that at the beginning and all that stuff, and I'm waffling on again. So let's continue. One moment. Okay, this is my servo tester. Oh, hang on, I've forgotten something. Just give me a minute. I tell you, I forget my head if it weren't screwed on. Right, yes. So this is with this cheapo tester. I said you can't see the frequency, but I can actually connect my oscilloscope to it, so you can actually see that we have here is the frequency. Again, forgetful. Here we go. I forgot to get my hand. Right, yeah. So we can see here that the frequency of that's the output of this cheapo thing is well 49.8. Basically, it's 50 hertz, and we can see the period there, which is 20 microseconds. Let's make that bigger. So, oh, we still want the thing in shot, don't we? Right, yeah, so that's better. So you should be able to see that now, 20.8 microseconds. So that's the difference across the top here that I was showing you. And then we've got then 20 microseconds there, giving you the frequency here. I should really put the period on, the duty on there as well, actually. One moment, I'm going to reset these numbers down at the bottom. Get there in the end. Right, yeah. So, yeah, we can see the frequency, 49.7 thing. Well, it's 50 hertz. So basically, that is from this point to that point, and so on. So we get lots of those. So we get one every 20 milliseconds. That's the period. And then we get the pulse width, which is the length of this pulse. So at the moment we're in the center, so we're getting 1.5 milliseconds. And if we can watch this as I rotate this knob anti-clockwise, and then we go up to, well, it's gone up to 900 microseconds. Which is 8.9. Well, it's 9 milliseconds really. No, it isn't. It's 0.9 milliseconds basically. And then if I move it the other way, we can see that it gets wider, and it should go up to around about 2. Well, it's a little bit above 2, so it's slightly offset by, I would say, 0.1 millisecond really, because it goes down just below 1. So if I just move it there we go, 1 millisecond. There it is at 45 degrees. So yes, so I forgot to show you that. Let's get back to my servo tester. Right. Alright, so here's my servo tester. Let's turn it on. So basically what this consists of is a STM8 103 microcontroller here. At the moment it's in my prototyping board, and so I'm actually running this at 3 volts, but my screen wants 5, this wants 5, so I've got a logic converter here for the moment, but once I've turned this into an actual PCB, this will disappear, because this will actually run at 5 volts, and that's what I'm going to make it run at, 5 volts. But it's just that while I'm programming this, the programmer is only 3 volts. So if I ran it at 5 and stuck my programmer in it, it would blow my programmer up. So I'm just running this at 3 volts at the moment. So that's it. And I've got 3 buttons here. I don't know if you can see them. See if I can just tilt it a bit. I've just got 3 buttons there. One little button and a pink one and another white one there. So basically it's got 3 buttons. the microcontroller. It's got display, OLE display, and out of shot. This is my rotary encoder. It's just one of those encoders. So this, you can rotate this and press the button and switch between two modes. Let's just move that up a bit, and so this is in shot. So you can see me turning the rotary encoder. So just so you can see me turning that. You can see the servo move. What these three buttons do, they put it into the center, so we can have it in center, and we can have it all one way, which is, this is actually, what's it say there? This one's at 2 milliseconds, and this one is at 1 millisecond. So they're just presets basically. So we've got 1 millisecond, 1.5 millisecond, and then 2 millisecond. And you can see it just turns the same. And what I'll do is I'll bring my oscilloscope. I've attached my oscilloscope as well, so I'll bring my oscilloscope in. Oh right, hang on. Let me just move this out of the way. Let's move that down here. Move my hand a minute. There we go. So you don't need to see the microcontroller. So I've shown you. Well, yeah. I'll leave it like that. That's okay, isn't it? What I can do is I can put the encoder over there, so you can see me turn that, and you can see me press the three buttons, and we can have this really extended out there. How's that? Yeah. So you can see there down at the bottom we've got 2 milliseconds. We've got a period of 20 milliseconds, and we're at 49.77 hertz, basically 50 hertz. And so what have I got? So we have it at 2. So if I just go all the way back to 1 by pressing this button here, if I press this button, that sends it to 1 millihertz. And if I send the middle button, that'll give us 1.5. So we've got 1.5 milliseconds, which is in the center. And then if we connect the other button here, press the other button, that should send it to 2 milliseconds. 2 milliseconds, which sends it the other way. So that's pretty much what we had on the cheapo servo tester. I'll just put it back into the middle with this middle button. There we go. But we also have this encoder here. So I've got my encoder, and you can't see the display. So the display is the key bit of making this. I'm going to set up the display so you can actually see it. So one moment again. There we go. You can see the display now, which is here. It says servo tester. It says it's at 0 degrees. That's just give you an idea what angle it should be at. The fact is that when we go all the way one way, I'll just press these buttons again, so go one way. That should actually be at -90, but because it's at 1000 microseconds, you can see that on there. So you can actually see the actual microseconds on this tester, so you know what you're actually setting. And you can also see that we've got the square wave, which is same as what we have down here. So this should actually match up with what we have here as well. So you can actually see what we are actually saying. This is the difference is the having a display with the tester. So we can see at 90. So if I press the middle one now to send us to 1.5 milliseconds, we can see that we've increased our pulse width here, and you can see it there. What I'll do is I'll go between 1.5, which is what it reads here, 1500 microseconds is 1.5 milliseconds. So I'll just go between button 1 and button 2, and you should see that the actual pulse width should change. So you can see it get narrow, and you can see it get wider. And if we go across to 2 microseconds, 2000 microseconds, which is 2 milliseconds, plus 90, you can see it's wider. So if I go from button 1 to button 3, you'll see this change. And you can see the same change down here from my oscilloscope. So what I'll do is I'll just use 2 fingers and go from 1 and to 2. And you can see that my little application here that I've made actually shows the pulse width. Let's go back to the middle, and we're at 0 again. So one way is sort of 90, right, which is the 2 millisecond, and the other one is minus 90, which is the 1 microsecond. Now, as I was saying before, on the data sheet it says that now this is as far as you can go. Oh, this is as far as you could go with this thing. That's all this does, is as far as you go. But the thing with mine now, because they've started going beyond the 1 and 2 microseconds, we can actually use my little wheel, my encoder switch, and using the encoder switch, if I rotate, let's try and get it in shot, there we go. So if we rotate the encoder, we can actually go, let's go the other way, we can actually go below the 1 microsecond, and we can actually wind down all the way to 0.4 microseconds. So that should go down to 400. 400 microseconds, which is 0.4 milliseconds. So you can see that the arm now has rotated even further, and you can see that the pulse width here, hang on, so you can see the arms moved further, and you can see the pulse width has reduced even further, because now we're actually down to 0.4 milliseconds, which is 400 microseconds. Oh, and while I remember, I nearly forgot, can you see that when I rotate my encoder, it goes by 10 microseconds at a time? And that's because if I went by 1 microsecond, it'd take forever to turn the wheel. But also, in the spec it said it had a dead bandwidth of 10 microseconds, so it doesn't change until you actually move at least 10 microseconds before it recognises that there's been any movement. So I've just made my tester adjust in 10 microseconds steps. So it'll just go to 20, 30, 40, and then you can see that the microcontroller is actually turning with it, the servo's turning with it. And you can see there from my oscilloscope that our pulse width is getting wider, and we can see that it's getting wider on the display as well. So I'll just turn it all the way around, so you can actually adjust your servo to any position within 10 microseconds. And obviously it only went up to the other tester only went up to 2 microseconds. So if we go up to 2 microseconds, gone past it there, 2 microseconds, which should have been hang on, I've gone past it again, there we go, which should have been 90 degrees. It's only 45ish, but we can actually go beyond, and it says it went up to 2.4, did it? But we can actually go up to 2.6 with my tester, so you can test how far it will actually go. So there we go. So if you're using a microcontroller, you're not actually sending the standard pulse widths to these servers. You are actually sending extended pulse widths to make them go through the 180 degrees, and that's a reason for my servo tester. So let me just, I'll just put this down, and what I'll do is I'll show you the other feature. Let me just center it again, so I'll just press this button. That gives us our preset middle. Sets it at 50. Even though it's extended as the pulse widths on these servos, the middle will always be 1500 microseconds. That never changes from servo to servo. Everything goes one way or the other from 1500. Right, yeah. So also with the encoder, the encoder wheel on my thing, we also have the period down here. At the moment, we are at 20,000 microseconds, which is 20 milliseconds, which is down here. You can see there, 20 milliseconds. But we can also change that as well, because what we'll find with today's servos, they're not all analog. They're now digital. They have a microcontroller inside of them. Back in my day, show you my age, the servos used to be analog, and you used to have a comparator that compared a voltage from a voltage sort of created from the pulse width against the voltage from a potentiometer on the end of the horn that rotates, and from this it compared the two and moved the horn until the comparison was zero. But now we've gone digital, and that's the reason why we can actually go beyond the 1 microsecond, the 1 to 2 microseconds. We can go beyond that now, because we've gone digital, and we can use those, extend the pulse width of the pulse. Also, because we can extend the pulse, and we're using a microcontroller, we can up the frequency from 50 Hertz to, with some servos, you can go up to 300 Hertz. So you can actually control it faster, and it'll update faster. And what I've done, if we press the wheel, if we press the wheel on my encoder, it'll move this arrow on the left to period, and we can adjust that. So I've just pressed it, and now that we're on period, if I turn my wheel, I can up this to 100. Oh well, I've gone too far. There, go up to 100. Can you see that we've increased here, and we've also increased on my screen as well. And if we go to 150, we can see we've increased again, and we're increasing here. We're doing them more often, these pulses now. They're getting closer together the faster we go, because this duration remains the same, but we do it more often. And so if we go to 2, and then we've gone to 250, and then we can go up to 3, so 300. So you can see that we're actually updating the servo 6 times as quick as we were at 50 Hertz. And if we click back, if I press the button on here again and click back to duty, we can see that this servo is digital, because it will actually receive the pulses at this speed. This is the actual speed that I'm actually sending the pulses to this servo, and can you see that at a higher speed you've got more control as you adjust. And let me just try it with the buttons. So I'll just do the buttons. That goes all the way around the middle. And you'll find that at this speed you get less jerkiness as well, less of that chatter you get from servos, because you're always constant. You're updating them 6 times as fast. So that was another reason for making my my servo tester. So let me just I'll just click to the other one, and I'll just reduce the speed again, and you can see that this corresponds to this down here on my, and you can see exactly what you're sending to the actual server. You've got the actual value and the frequency that is being sent, and you know exactly what your server can do at what frequency and at what pulse width. Whereas with the other testers, it just turns it. Yeah, it turns and it works. Yeah, that's good enough for me. But if you're doing some accurate stuff with servos, then you need to know what accurate. Once you start coming to robots, and you're moving a leg and an arm, or something like that, or maybe you're doing the little eyes or something, and you want to turn them with some precise movements, you need to know what actual position you actually want and send to that servo, and then you can take all this data and you can put it into your program that controls the servo. So yes, it's a more complicated tester for a more complicated job. Right, so I'll just pause a minute, clean up. Well, okay, I hope you enjoyed that video, and if you're into robotics and using servos, you may find this of some interest. My next step is to design a circuit board, PCB, for this. I don't know if anybody's interested on how I go about doing that. I've done a brief, well, I think I did it when I did the Edison record player. I think I did sort of the way I did things. I don't know if anybody wants to see me do it again, or whether you just want to just see the end result once I've designed the PCB and made the PCB, and see what it looks like once I've done it. Let me know if you're interested in learning how to use KiCad, and we'll probably do a video of it. Thanks for watching. If you've made it to the end, thank you very much.